Welcome back, students. Now we are going to continue the SN2 reaction, then factors affecting SN2 reaction. Can anyone write in the chat box whether the voice and the screen both are clear or not? Voice is clear. Student, can anyone write in the chat box? And screen is clear. Whether the screen is clear or not. Students. Okay. Now, this is the SN2 reaction. Any doubt, student? Quickly. Any doubt? No. So in the first half, we have discussed the SN2 reaction, and the general representation of SN2 reaction is this order equal to 2. So rate of the reaction is represented or is proportional to the concentration of haloalkane and nucleophile. So rate can be represented as the product of, that is rate constant, haloalkane, nucleophile, order is 2. So mechanism, it follows concerted mechanism. That means bond formation and dissociation both are taking place simultaneously. So the name is concerted mechanism. Nucleophile attacks the carbon exactly from the opposite side of the living group. Okay, जो living group थो तार just opposite side रो nucleophile attack करिवो. So after the attack, what will happen? Nucleophile starts making the bond, and simultaneously the bond between living group and carbon starts dissociating. बुझ पारलो? गोटे साइड रे nucleophile carbon the bond formation होची, आउट साइड रे carbon और living group the bond dissociation होची. जो both process होची formation और dissociation इधर simultaneously होची. ता माने nucleophile जेमती stronger bond बने चलुची with the carbon, same time रे carbon and living group bond कौन होची dissociating चलची और माने weak हवा weak हे चलची. So finally कौन हबो? The nucleophile makes a stable bond and the living group is released. Nucleophile makes stable bond and the living group is released. So this is the overall mechanism. So next now what is the graphical presentation? Then graph देखिए, you can take this is the reaction coordinate and potential energy. A reactant, this is product. Okay, so reactant makes the product through the intermediate known as the transition state or activated complex. So this is transition state. So हमें देखिए reactant रे कौन अच्छी ना nucleophile plus haloalkane. Product रे कौन अच्छी plus living group or X minus. So transition state nucleophile. So this is known as transition state. Our transition state is highly unstable, more energetics. Highly unstable and more energetics. So student draw कर दियो quick. It is a graphical representation of the SN2 reaction. Okay, graphical representation of SN2 reaction. So over, friend, I hope all of you are drawn. Any doubt up to this? Any doubt? No. Okay. Now we are going to discuss the next one, that is factors affecting SN2. Factors affecting SN2. So under that, first, nature of halo alkane. We'll discuss the factors in the SN1 factors देखते हैं, SN2 रे भी factors देखिए. First of all, nature of the halo alkane. So how the halo alkane can affect the SN2 reaction? So it can देखिए कौन? In halo alkane, the reaction goes through the formation of transition state intermediate. So the transition state रे carbon seems to be pentavalent. Carbon seems to be pentavalent. So the transition state रे carbon pentavalent अच्छी, हमें एमडी कोई करे. It is highly crowded, right? The transition state is highly crowded. So the transition state highly crowded hela. Then are you getting that there is a transition state highly crowded hela? ताले कौन होगा? ना steric hindrance plays a main role in deciding the SN2 reaction. Again repeating, steric hindrance plays a main role in deciding the SN2 reaction. हमारे जोटी अधिक steric hindrance होगा, जोटी अधिक steric hindrance होगा, सेटी कौन होगा? कोई स्टूडेंट SN2 reaction होगा chances कम रहेगा. Yes or no? ताले यदि हमें इसे देखिए reactivity order कौन होगा? ना primary greater than first of methyl, greater than primary, greater than secondary, greater than tertiary. जोटी की हम SN1 देखते ले, SN1 order कौन सा? Tertiary, greater than secondary, greater than primary, greater than methyl. It is reverse. The reason कौन? ना reason है ना tertiary is highly crowded and methyl is least crowded. So least crowded है से SN1 reaction faster दबो. I highly crowded है sorry, least crowded SN2 reaction faster दबो. Or highly crowded that will give SN1 reaction more faster. Second, nature of, note down the points, nature of living group. Nature of the living group. And जो living group, better living group थी वो. Okay, better the living group. Living group better थी वो. It gives, so दो reaction है, SN1 हो, SN2 हो. It gives nucleophilic substitution more easily. It gives nucleophilic substitution more easily. Okay. So this is nature of the living group. Then nature of the nucleophile. Nature of the nucleophile. Telco, better nucleophile अछि, जहाँ better nucleophilicity अछि, से easily SN1 reaction दे परिबो. More the nucleophilicity, more easily it gives SN2 reaction. SN reaction दो, माने nucleophilic substitution SN1 हो SN2 हो से more easily दो. Okay, friend got it? nature nucleophile kon asla na more the nucleophilicity of the nucleophile, more easily it gives SN2 reaction. So next kon asiba, next asla concentration of nucleophile. That means whether by changing the concentration of the nucleophile, there will be any change in the nucleophilic substitution or not. There will be any change in the nucleophilic substitution or not. Let us student. Then we देखिबा rate determining step or slow step. In the slow step, both haloalkane and nucleophiles are present. जोटा कि SN2 रे SN1 रे नथा. SN2 रे nucleophile is also present in the slow step or rate determining step. यदि nucleophile अच्छी ताले हम कौन कहेगा? By increasing the concentration of the nucleophile. Again repeating. By increasing the concentration of the nucleophile, rate of SN2 reaction increases. Okay. So with increase in concentration of nucleophile, rate of SN2 reaction increases. Note down, rate of SN2 reaction increases. Student note कर सकता आउ कौन फैक्टर আছে को हमें देख लिए the first nature of the living group, haloalkane, then natural living group, then nature of the nucleophile, concentration of the nucleophile. How can factor है को? What are the other factors? मन पकाओ क्षेत्र कौन थिला? कोथरे in your SN1 reaction. How come factor थिला? What is the stereochemistry factor रहिबो? Yes or no? Stereochemistry गोटे factor रहिबो. How come factor रहिबो को? First हम देखे stereochemistry. How would nature of the solvent? Stereochemistry, then nature of the solvent. Okay. Sal को stereochemistry कौन रहिबो? What will be the stereochemistry? You can tell what will be the stereochemistry? It is stereochemistry however, it goes through complete inversion of configuration. It goes through complete inversion of configuration. एटी कहीं complete inversion of configuration of को? Why it goes through complete inversion of configuration? Yes, because I get complete inversion of configuration of now because the nucleophile attacks exactly from the opposite side of the ligand. Again repeating, the nucleophile attacks exactly from the opposite side of the living group. Okay, since the nucleophilic attack is opposite side of the living group, so it goes through the complete inversion of configuration. It goes through the complete inversion of configuration. Okay, students. That's next. Next time देखिएगा. That is nature of solvent. In SN1, the reaction goes through the reaction कौन होता है? Reaction takes place in polar protic solvent because polar protic solvent helps in dissociating the bond between carbon and living. Okay. Polar protic solvent ताको help करथिला. जदि हम एठी देखिबा एठी कोन ना polar aprotic solvent. polar aprotic solvent. Okay, कहेंगे ना polar aprotic solvent रे देन नबा polar aprotic solvent presence रे एटी कोन हबो ना जो living group अछि nucleophile अछि that will be highly solvated. यदि nucleophile highly solvated हबो तार nucleophilicity decrease हो again repeating यदि nucleophile highly solvated हबो तार nucleophilicity decrease हो ताले एटी कोन हबो ना the reaction goes through polar aprotic solvent. polar aprotic solvent. Polar aprotic solvent हम कौन डिस्कस करथिले THF tetrahydrofuran DMSO dimethyl sulfoxide. Okay, so these are the और acetone भी नहीं परिवा acetone is polar काइना कार्बन ऑक्सीजन डबल बॉन्ड अछि but it is aprotic काहेकि it cannot release a proton बुझा पड़ला it cannot release a proton ताले हला nature of the solvent. How would factor अछि in SN2 reversibility. Reversibility. जेमते हमें ए रिएक्शन देखो स्टूडेंट see here we are taking the nucleophile and here halide ion is released. जो halide ion जो देखिबा halide ion means it contains negative charge. It can also act like nucleophile. It can also act like the nucleophile. ताले जे लिविंग ग्रुप अछि से nucleophile हे परियो as a nucleophile से living group बोली act कर परियो ताले once the living group is released, are you listening? Once the living group is released, it has the tendency to reverse back or to attack. It has the tendency to attack the nucleophile to the carbon center again. It has the tendency to attack the carbon center again. जैसे carbon center को attack करियो ताले ता नेचर कोन हबो यदि से carbon center को attack करियो then what will be its nature? It will be reversible. The reaction reversible is ताले once the product is formed, the living group has to be separated from the carbon center. The living group has to be separated from the compound. And ताको कौन करिया पड़ो ना living group को हमको easily ताको separate करिया पड़ो. Reaction लिखिया. बुझा पड़ला? Okay students, एटा लिखि दियो reversible nature. Quick. Students clear? Any doubt? Up to this, any doubt? चलो मैं reversibility तो द लास्ट टॉपिक रे कोन लिखिबा ना the leaving group released, note down, the leaving group released is also a potential leaving group is also a potential nucleophile. So it can attack the carbon center AG. So it can attack the carbon center AG. Reversible. So once the leaving group is released, we have to separate it from the carbon center. Okay, students. This is all about the SN2 reaction. तापरे हमें गोटे क्वेश्चन SN1 SN2 डिस्कस करियो. Can you try some questions? Right, question number 2, 3, 4. I think screen is visible. Try question number 2, 3, and 4. Quick. Quickly note down, then we'll discuss. Option देइछि, objective question अछि, option देइछि, हमें try करो. तापर हम डिस्कस करियो. Take some time, student. Write the questions. Delhi. I hope all of the writing. You want to complete all? Write in the chat box. After completing, write in the chat box. Wait. Now we are going to discuss this one first. What is written? Give statement one: high concentration of strong nucleophilic reagent with secondary alkyl halide. Jadi high concentration of nucleophile अछि, right? Jadi high concentration nucleophile अछि. So nucleophile concentration को के मान nucleophile concentration को reaction को affect करि पारे. SN2 reaction को affect करि पारे. Okay. Nucleophilic reagent with secondary alkyl group. हम जानते हैं यदि primary थियो that will exclusively give SN2. यदि tertiary थियो then that will give SN1. Tertiary SN1, primary SN2. यदि secondary अछि that may favor SN1 as well as SN2. So से कहाँ पे depend करिवो ना से depend करिवो some other reagents, some other factors. कौन other factor? यदि bulkiness अधिक थियो that will favor SN1. यदि less bulky थियो then that will favor SN2. एटी कौन देछि? Do not have bulky substituents will favor SN2. Correct. Okay. Secondary माने SN1 SN2 दीटा के परिवो यदि bulky थियो ताले से SN1 को फेवर करिवो यदि less bulky थियो से SN2 को फेवर करिवो तापर कोन यदि strong nucleophile अछि यदि strong nucleophile अछि से काहा फेवर करिवो SN2 को फेवर करिवो बुझा पड़ला अच्छा नेक्स्ट ताले statement 1 correct अछि a secondary alkyl halide when treated with large excess of ethanol secondary alkyl halide ethanol nature कोन polar protic solvent यदि polar protic solvent अछि then it goes through SN1 reaction follows SN1 mechanism एटा भी ठीक अछि ता माने statement 1 statement 2 both are correct now the question is whether one is the correct explanation of other or not. No, it is not the correct explanation. So the correct explanation may. So the correct explanation may, according to the option given, option D, both statement 1 and 2 are true. Okay, but not the correct explanation. I'll call it. It is simply the option nahi. So option D is correct. Next, which of the following solvent is suitable for SN1 reaction? Which of the following statement is solvent is suitable for SN1 reaction? Now, SN1 reaction is favorable in polar protic solvent. SN2 reaction is favorable in polar aprotic solvent. That option कौन है B. Okay, polar protic solvent. Then question number 4. Which is most reactive nucleophile in polar protic solvent? Polar protic solvent नेले हमें देखिए some of the nucleophiles will be highly solvated or protonated. So it highly solvated किया होगा. So highly solvated होगा जो nucleophile का size smaller है. कहाँ का size smaller है? Fluoride का size smaller है. अगर the fluoride highly solvated होगा, even it can make hydrogen bonding. Fluoride can make hydrogen bonding with water. यदि fluoride hydrogen bonding with water बनेगा, तब कौन होगा? ना से तारो nucleophilicity decrease ହେଇଯିବ କୋଜେ polar protic solvent a polar aprotic solvent रे ହେଇଥିଲେ fluoride must be the most or the nucleophilicity of fluoride is more in polar aprotic solvent than others the polar protic solvent नबो ताले nucleophile बड़ा fluoride ଅଛି that will be highly solvated the nucleophilicity decrease ହେଇଯିବ so answer कोन होबो I minus in polar protic solvent, F minus in polar aprotic solvent. Okay, so answer is D. So question number 1 answer question dodam dite first assertion is an answer D. Then next question SN1 polar protic it is I minus. Okay, friend clear. Now these two questions. These two questions. In the given reaction 3-bromo 2,2-dimethyl butane 3-bromo 2,2-dimethyl butane ethanol presence rate what is the product I will consider the following reaction this So the reaction proceeds with 90% racemization. The reaction may follow. Okay. So it is a question. Even question number 6 भी तुम try कर पाइयो. जो question number mention अच्छी 6, 7, 8. फटाफट friend. 6, 7, 8. Take 5 minutes and try. अच्छा तो क्वेश्चन नंबर 3 डिस्कस करें यदि किसी का डाउट अच्छी देन क्विकली आस्क एनी डाउट नो ओके बाकी 3 क्वेश्चन टोटल पहले ट्राई Student, I hope all of you tried. Okay. See, the first question is which of the following, which is the most reactive nucleophile in polar protic solvent, aprotic solvent? So it is fluoride minus, just take a पूर्व में discuss करते. Then question number 7. 7 is in the given reaction 3-bromo 2,2-dimethyl butane. In the given reaction 3-bromo 2,2-dimethyl butane. तो हमें देखिए स्ट्रक्चर हमें स्ट्रक्चर दे ड्रॉ करिबा 3-bromo okay butane 3-bromo 2,2-dimethyl butane. Okay. Ethanol. So what will be the product? What will be the product? It product from bonibo dekho. Now the product will be the ethanol nucleophile of this is C2H5OH. So which one will be the nucleophile? The nucleophile is C2H5O minus. Okay, C2H5O minus. তাহলে ঠিক product কোন হবে? Now the product is this is the product. So how to write the mechanism? How to write the mechanism? The mechanism কেমনে লিখবে? This is polar protic solvent. So polar protic solvent means the reaction will go through the formation of carbocation intermediate. Okay, the reaction will go through the formation of carbocation intermediate. তাহলে এটি carbocation intermediate কোড বনিব, where the carbocation intermediate will be formed. First, it is then methyl shift. So after methyl shift, this is okay. This is the intermediate. So since this is the intermediate, agu kon hobo na it will be attacked by the nucleophile C2H5OH O minus O C2H5 CH3 CH3. তাহলে না কোন গেল অপশন সি 2-ethoxy 2,3-dimethyl butane. 2-ethoxy 2,3-dimethyl butane. This is the product. Then last one তুমি লিখি দিব. Consider the following. So the reaction proceeds 98% racemization. Then answer racemization কোডে হবে? Racemization will take place in SN1 reaction. So SN1 reaction এর racemization হবে তাহলে SN1 কোড হবে মানে অপশন কোন হবে? That is SN1 mechanism. Option is A, that is SN1 mechanism. I think it is clear. Now we are going to discuss next SNI. SN1 SN2 discuss कर ले, तार related is question भी discuss कर ले. Now we are going to discuss SNI, nucleophilic substitution internal reaction. Can anyone share that whether any difficulty is there? Any difficulty, student? Write in the chat box. I'm waiting. Any difficulty? No? Okay. Now we are going to discuss. That is the SNI reaction. SNI reaction. So SNI reaction, what is the name of SNI? What is the full form of SNI? Nucleophilic substitution internal reaction. Nucleophilic substitution internal reaction. Okay. So it is nucleophilic substitution internal reaction. Nucleophilic substitution. So then why the name is internal reaction? Because in this reaction, the nucleophile is prepared internally. The nucleophile is prepared internally, so the name is nucleophilic substitution internal reaction. Okay, nucleophilic substitution internal reaction. So a reaction let them body this. How to prepare haloalkane from alcohol? So it is thionyl chloride. So thionyl chloride, it is the best method. It is the best method to prepare chloroalkane from the alcohol. Right? Now, the products are SO2 and HCl, along with the products are SO2 and HCl along with haloalkane. So the SO2 and HCl both are the gaseous products. These two are gaseous products. We have already discussed. So the gaseous products side products of the gas that can easily be separated out. Easily separate. Okay. So now we are going to discuss the mechanism. Mechanism now alcohol. So this alcohol contains lone pair. This will be attacked by clear. This will be attacked. So next So this is ROH SO minus chlorine. Is it clear? O minus chlorine, and oxygen will have positive charge. So next step, this O minus GH that will try to make the bond. So chlorine will be released as the leaving group. So in the next step, what will be the product? This plus S, one second. S double one O Cl plus Cl minus. Next, leaving group अच्छी Cl minus सिवे alkyl group का attack करियो. जैसे alkyl group का attack करियो, ये release होगा. So हमें लिख परियो RCl plus Okay, this one is clear. This one is clear. Next kono na oxygen tries to make double bond. কাহিଁକି নাম জানছে নাম জানছে কোন না oxygen sulfur. This is p pi d pi bonding. So p pi d pi bonding is stronger. So what will happen? This is RCl plus here release ହେଇଯିବ SO2 plus HCl. So this is the overall mechanism. Take 2 minutes and quickly note down the steps. ତାପରେ ବାକି जो explanation and the discuss करिए. And quick. Okay. Then all of the writing. Now, any doubt? Then if any doubt, then quickly let me know. Next is why the name is internal. Now, since the nucleophile is generated internally, so the name is nucleophilic substitution internal reaction. काहे के देखो आमे जो रिएजेंट नहीं थे रिएजेंट रे क्लोराइड आयन डायरेक्टली नहीं रिएजेंट में कौन नहीं थे SOCl2 नहीं SOCl2 रो क्लोराइड आयन इंटरनली जनरेट होता again repeating SOCl2 रो क्लोराइड आयन इंटरनली जनरेट होता so the name is nucleophilic substitution internal reaction so the name is nucleophilic substitution internal reaction clear अच्छा next now what is the stereochemistry of this reaction what is the stereochemistry of the reaction its stereochemistry कौन थिला this reaction has the stereochemistry that is retention of configuration हम देखते ले SN2 inversion SN1 racemization SNI retention ताले retention कहीं की it retention कहीं की अब को because the nucleophile attacks from same side where the living group is present तो देख परियो जोड़ी लिविंग ग्रुप साडे लिविंग ग्रुप अछि सेही साइड रो ही न्यूक्लियोफिलिक अटैक होउ यदि न्यूक्लियोफिलिक अटैक सेम साइड रो होछि तर हम कोन कहबा देखो इट इज कंप्लीट रिटेंशन ऑफ कन्फिगरेशन ओके तले हम कोन देखतिले SN1 racemization that means more inversion and lesser retention SN2 complete inversion SNI complete retention note down take 2 minutes quickly note down this quick and quick note down फिर नोट करछो Okay. Now we are going to discuss the last one, that is NGP. It is neighboring group participation. Neighboring group participation. Okay. তাহলে NGP কোন হবো না, this reaction takes place by following inversion twice. So overall reaction is retention of configuration. So the overall reaction is retention of configuration. Okay, বুঝা পড়লা? Now কেমনে তাহলে লিখিবা? Neighboring group তাহলে লেখো if at the adjacent carbon of the leaving group an atom or group is present, which can extend its electron pair to make temporary bond with the carbon containing the leaving group from its opposite side. It is first one. Then at the lecture take 2 minutes. Take 2 minutes and write on this. I hope all of you are writing. Quick. নোট করছো? তাহলে which group can act as the neighboring group? Yes. Which group can act as the neighboring group? Na তারপরে lone pair থিব or negative density থিব. Yes or no? Which contains lone pair or negative or electron density. So it is clear. Just 1 second. So the examples of leaving group, it can be NH2, it can be OH, it can be phenyl, it can be O minus also. So these can act as the leaving group. Clear? This can act as the leaving group. So after this, next you can say, but I'm question number, an example number. This is Z. Z can act as the leaving group here. Z can act as the leaving group. তাহলে দি Z leaving group হবো, sorry, neighboring group. Z is neighboring group. So Z extends the electron density to this, which helps in dissociating the bond okay. So this plus L minus, this is the first step. This is the first step. Next next what will happen? Now step 2, attack of nucleophile to the carbon center from the opposite side of the cyclic ring, and hence a ring opening takes place, and hence ring opening takes place. Okay, তাহলে শুনুন বুঝে পারলো এটা? So next step কোন হবে এটা দেখো, nucleophile attack হলো. So the product will be Z nucleophile. So here inversion twice होची, leaving group of first or leaving group of opposite side रो neighboring group attack करूची to make the cyclic compound, and next one होची nucleophile attack करूची from the side where the leaving group was present. So the reaction goes through retention or configuration as the inversion takes place twice. As the inversion takes place twice, so the reaction goes through retention of configuration. Student clear? So write down this lecture তারপর আমি dictate করছি, take 2 minutes. Quickly note down করো. Okay, so last NGP is identified as the rate of reaction is much faster than the expected rate. ଆମେ ଯେତିକି rate କୁ expect କରୁଛେ ତାଠୁ much faster ଅଛି NGP. Sometimes it is 10 to the power x times faster than the expected rate. Okay, 10 to the x times faster than the expected rate. Okay, I think it is clear. তাহলে এটা কোন না NGP কে আমি কেমন জানিব? First ହେଲା the rate of reaction is much faster than the expected, that is 10 to the power x times faster. Second ହେଲା, second condition ହେଲା, this reaction goes through complete retention of confidence. This reaction goes through complete retention of confidence. Okay, the editor thibo, then the reaction is following NGP. Take 2 minutes, note kar diye. Right. Okay, if you have completed, then you can leave the class.